Okay, guys. So first and foremost, we are going to be not picking right up where we left off, but I figure the best thing for us to do for those of us who are able to watch these videos is to start with something new and something very, very simple. I promise you, the stuff we are about to do today is really, really simple. So just follow along. This is going to look very similar to what you're used to. Okay. So the way it's gonna work is I'm gonna go through this, talk about some stuff, write some things out, and that way y'all can come back and reference this at any point. So here we're gonna talk about two things: sample space and simple probability, as well as what's called a complement. All right, and it's really, really simple. So let's just go ahead and get started. So also, I'm going to go ahead and apologize for my handwriting. Actually, you know what? I'm just going to use letters here. It'll be real simple. So sample space describes all of the possible um, outcomes of an event. Oh, is it going to type weird? Let's see. Outcomes. Okay. So it describes all the possible outcomes of an event. Can I make it blue? Okay. And sample space can be displayed with lists, tables, or tree diagrams, and realistically, you're really only going to see well, you'll see tables, but like today, you're only really going to see a list or tree diagrams. Um, anyways, so now what we're going to do is, so there's two types of probability, but I kind of want to talk about them later. There's simple probability and compound, but we'll talk about that more later. So basically, this is it. So let's see these examples. Okay, I want you to see how simple this is. So if you look here, it says the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of the game? Okay, so this right here is a sample space. You have sample of things that could happen. Well, if you just take the time to think, there's only two possibilities. The first possibility, and most likely, is that the Patriots win. And I spelled it wrong. So the Patriots win. That's one outcome. Or the Dallas Cowboys win. Now I know ties exist. Okay. So we can go ahead and even add that in there. But realistically, there's not really many ties. Okay. But if you look at it like this, you can see that this is it. Sample space is New England Patriots and Dallas Cowboys. So therefore, realistically, either the Patriots win or the Dallas Cowboys win. There you go. Okay, so a number cube is rolled. I don't know why they use that word. Hold on, let's fix this. A die is rolled. In other words, like a six-sided die. What are the possible outcomes? Okay, well, it could be a 1, or a 2, or a 3, or a 4, or 5, or a 6. And that's the sample space. Right there. Boom. Sample space. This simple. Okay, let's go down a little bit. Because there is a little bit more to it, but just give me a minute. So here it says, for breakfast, Jamie can choose from cereal, eggs, or a muffin. Okay, so let me underline these first real fast. Cereal, eggs, or a muffin. She also gets to choose a drink. She can have coffee, orange juice, or milk. What are all the possible outcomes? How many total outcomes are possible? Let's work with that first one. What are all the possible outcomes? Well, let's think about this logically. Okay, so we're Jamie right now. Let's say we want to eat cereal. Okay, so I'm just going to go ahead and type this stuff out. So we want to eat cereal, right? Well, what are we going to have to drink? How about coffee? Okay, that's one outcome. Now, what if I decided to eat cereal, but then I got to drink orange juice? Now, what if I picked cereal, but then I decided to drink milk? Now, if you look at all this, there's no other possibilities because you have to pick one food and then one drink. This is one food with 3 different drinks. repeat. If I decided to have eggs instead, well, again, I could still have coffee as a drink. I could instead have OJ as a drink, or I could have milk as a drink. And that continues with a muffin, right? So if I chose to eat a muffin, then I could also have coffee as a drink. Or I could have orange juice. Or I could have milk. Okay. So here, this is not only, so the sample space is this stuff that's given to us, right? The possible choices, the possible things that could happen. And then this right here are the actual possible outcomes. So when it says what are the possible outcomes, well, these are the possible outcomes. How many total possible outcomes? Well, count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. 9 possible outcomes. That easy. Okay, so now here, that's a list. You could also make a table, right? So you could take the same information and put it into a big table like this, but I'm not going to bother with that because I'm confident that if y'all see the table, y'all will understand it. So let's look at this one because this one is kind of important. It's called a tree diagram. So it says a fair coin. They'll say that because sometimes coins can be weighted where it'll land on the heads rather than the tails to trick people. Anyway, so this coin's fail and it's tossed 3 times. It says, what are all the possible outcomes and how many total outcomes? So pay attention to this, okay, because we're going to use a tree diagram to do this. So let's say I flip 1 coin. Boom, I'm flipping a coin. Well, I have 2 possibilities. I could land on heads or I could land on tails. Now let's just come here for a second. Let's just mess with this heads. Let's just get rid of that tails and only mess with this heads, right? So let's say I flip it and I land on heads. Again, I have to toss it 3 times. So this is toss 1. Well, what about toss 2? Well, it could also be heads or it could be tails. And then what about toss 3? Well, if it was heads and then heads again, your options would be heads or tails. And the same here, if it was heads then a tails, then it would be heads, tails, and then again either a head or a tail. So you see how it keeps branching out, and that's basically what a tree diagram is. But notice, pay attention though. This is only if we get a heads first. So we have to come over here, and we also have to say, well, we could have gotten heads on that first flip, but what if on the first flip we got tails? Well, yet again, it could have been a heads or a tails. And then that heads could have been a head or a tail. And then this tails could have been a head or a tail after. So if you notice, this is the basically, God, I can't speak. Basically the possibilities of what could be happening, right? So I could flip a head and then it could go this way, or I could flip a tail and it could go this way. Okay, so now this is the key here for tree diagrams. Okay, is it says what are the total possible outcomes? Okay, so let me highlight this in red, right? So how many total possible outcomes? You have to count the very end of the tree diagram. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 possible outcomes. Please pay attention to that. You have to count the end of it. Alrighty, so I'm going to have to speed it up a little bit here because these only let me record up to 15 minutes, and we're about halfway there. Okay, so this is a little bit more important. Still pretty simple, but it's a little simpler. So probability is the likelihood, or in other words, the chance. Now I'm still going to type likelihood here, but it's basically the chance of an event happening, and is expressed as a number between 0 and 1. Probability will always be between 0 and 1 because this is how probability works in the world, okay? And it has to do with these specific terms. Unlikely, equally likely, impossible, certain, and likely. So let's start with these ones first, okay? Let's start with, where is it? Let's start with impossible and certain. Okay, so if I am certain that it's going to happen, it's a 1. Okay? If it is impossible, I'll go ahead and do this in the opposite color. If it's impossible, there's no way it can happen, then the probability of it happening is a 0. And that's basically how it works for the rest of it, okay? So basically, if a certain is all the way to the right and impossible is all the way to the left. So if we look here at equally likely, well, where do you think it would be? Well, right in the center. Half. So half means that it could be certain or it could be impossible. It's likely right in the middle. And then these are going to skew one way or the other, right? So unlikely is going to come over here because it still could happen, but it's likely that it won't. And then we can come over here as well for the likely. Again, likely means, oh yeah, sure, it probably will happen, but there's a chance it won't. Okay? So now let's just see a bit more when it comes to like examples or something. So here, read each statement and label it with one of the terms, right? So snowing when it's 40 degrees outside, it's impossible. Why is it impossible? Well, because, and actually I'm just going to draw lines here for y'all because it'll make it a little bit faster for me. Okay, so snowing when it's 40 degrees outside, impossible. Why? Because it's not cold enough. Burning your dinner if you cook it too long. I would say it's certain. If you put it in the oven for 3 hours and it's only supposed to be in there for 20 minutes, it's going to burn. Water boiling at 75 degrees Fahrenheit. Well, hopefully y'all know the boiling temperature of water, and if you do, it's impossible. Getting a ticket if you're speeding, likely. You might get caught, and if you do, you'll get a ticket, but you also just might not get caught. So it's only likely. Scoring 2 points on a safety in a football game. I would say that's unlikely, because if you know anything about football, safeties don't happen often, but safeties still do happen in football. There's plenty of games where people score points as a safety. And then here, a coin landing on heads when it's flipped. It could be heads or tails, so it's equally likely. Alrighty, let's move on to something a bit more important here. Okay, so now we're going to talk about what's called simple probability here. Okay, so simple probability is the ratio of possible. Let me rewrite that for you, so it's a little bit easier to read. Possible outcomes to the total number of outcomes, and basically it looks like this. So let's say we're looking for A, whatever A is. Okay. So basically it works like this. Whatever we want, again, so I do want to emphasize this too, is that it's a ratio. And again, remember, a ratio is a fraction. So basically, if we want A goes on top, the total goes on the bottom. And I don't know why I'm bothering to write right now, or use this, okay? So what we want, A, is on top, versus every possible outcome, it looks like this. So for example, okay, we can do a real quick one because we are running out of time on this video. So let's say I was going to, and actually what we're going to do is we can skip a complement, okay, and I'll actually just mark that out real fast, okay? We don't have to worry about complements right now. So let's look at this 7. Okay, so it says, what is the probability of choosing a marble with stripes? Well, if you look here, there is only 1, 2, there's 2 with stripes. So that means 2, which is what we want, out of 1, 2, 3, 4, 5. 5 total. Therefore, the probability of getting stripes is 2, these 2 right here, at least in my mind those are stripes, out of the 5 total circles. And that's how simple probability works. It's just a fraction with what you want on top and the total number of things it could be on bottom. I'll let you guys try this one, but I do literally only have 20 seconds left and I gotta end this. So go to Google Classroom, go to Pearson. It should log you in automatically. The work's assigned through there. If it doesn't, my main mode of contact right now is through Jupyter Ed. So make sure you have Jupyter Ed. If you don't, send me an email with your Gmail account. Thank you. Y'all have a wonderful rest of your day.